Hi, my name is Reshma Raj from Civil Engineering Department, and this time I'm going to talk about truss analysis. So let's dive deeply on truss analysis, and in the starting I will talk about what is truss and all. So everybody will heard about truss, and most probably in houses who is using asbestos sheet are doing some kind of a very small truss work in their home itself. So a truss is a structural component, okay, which is a slender member. Slender means having high or narrow with cross-sectional cross-sectional dimension is known as slender members. So slender members is joined together at either of their endpoints. uh, so planar trusses lie in a single plane. Typically, a truss is a joint framed structure which is designed to sustain inclined, vertical or horizontal loads occurring at or between its points of supports and points of support. So it has certain characteristics. Uh, so in the picture you can see there are straight members, so which is connected from top chord to bottom chord is known as straight members. Members that are connected at the intersection by means of any kind of frictionless pins or hinges is termed as straight members, and so the members arranged that the truss is loaded only at the joints. Next, we can talk about the components of truss. In the components of truss, you can see the upper portion which is known as top chord. That top chord or that inclined or upper member of the truss that holds the roof deck and primarily uh, experience the compressive stresses. So in the top chord it experience only the compressive stresses, and it will be inclined also. And in the bottom you can see about the bottom chord. So of course the upper portion is about inclined member is about compression. That bottom chord is always in tension, and it is a lower member that forms the base of the truss, which supports ceiling loads and resist tension, as I talked about. In between you can see the webs. So the internal members, which is either diagonal or vertical, these internal members connecting the top and bottom chords, and it will also provide stability, and it is forming a kind of triangular patterns, and it will also distribute loads from top to bottom also. And you can see some joints, panel points, the points where the top chord, bottom chord and the web members meet at a point, that is known as a joint. So these joints will be either connected through pin or hinges, as I talked about. Next is gusset plates, which is also known as nail plates. So metal plates with teeth that connect the wood members together at joints to ensure the structural integrity. So these are the very important things we have to come across while we are talking about uh, where we are talking about truss. And another specific components and features we can talk about is like apex or peak, which is known as the highest point where the top chords meet. Next is called as heel, the point where the top and bottom chords connect at the support. Next is bearings. So what are bearings? The structural support where the truss sits on a wall or beam is called as heel. Next is bearing. So next is cantilever, the part of the top or bottom chord extending beyond the bearing support. Next is pitch. The angular slope of the top chord is known as pitch, and bracing members that connect trusses together to ensure stability, such as longitudinal bracing. So these are the important components of truss. Next, we talked about basic type of stress. As you see in the picture, first one is pitch truss, which is a very commonly used truss, and it is characterized by using triangular shape, and more often it is used in the roof construction. And I talked about certain the truss, the starting mostly in some homes or in some houses we have truss work. That truss work is known as pitched truss, which is so simple in construction. Next is parallel chord truss, uh, because as its name indicates, it's parallel top and bottom chords. The top and bottom chords are in parallel, and it is often used for roof construction, which has a length kite. Okay, that is known as parallel chord trusses. And another kind of truss, as you see in the picture, is flat truss, which doesn't have that much interior height, is known as flat truss. And queen post truss. Queen post truss is a typical cone shaped, it is known as queen post. And bowstring truss. Bowstring is that carried so much of loads, kind of warehouses we can able to see bowstring truss. Then king post truss. King post truss is typically a kind of inclined roof, inclined top posts, which is connected parallel to each other, is known as king post. And lenticular truss. Lenticular truss, which will be used mainly in long span bridges. Next is lattice truss. Lattice truss mainly used in we can say about tunnels. So analysis of truss structure. First assumption is to design both the member and connection of a truss. The force in each member for a given loading must be determined. As usual, load should have to be determined. Then two important assumptions are truss members are connected by smooth pins, and all loading is applied at the joint of the truss. Then this stress produced in these elements is called as primary stresses because of the points or hinges. These elements is known as the primary stresses. The pin assumption is valid for bolted or welded connection if the members are concurrent. However, since some connections does provide some rigidity, so that rigidity provides the bending which will be introduced in the member is called as secondary stress. The stress induced due to the bending is known as the secondary stress. And next is secondary stress is not commonly provided in everywhere. And another one is all loading is applied at the joint of the stress. Since the weight of each member is small compared to the member force, the member weight is often neglected. And because of these two assumptions, each stress member is a two force member with either compressive or tensile force. And next one is we can talk about much about truss analysis in the upcoming video. Thank you.